Good morning, everybody. It's almost time, so I'm going to go ahead and introduce our next speaker. Nic Halverson is a co-founder and CEO of Occuspace, a leading occupancy monitoring and space utilization technology company. With a background in engineering and a passion for data-driven decision-making, Nic has spearheaded the development of non-intrusive AI technology that helps higher education institutions and facility managers optimize their physical footprint. Under his leadership, Occuspace has partnered with universities across North America to transform raw occupancy data into actionable insights for better campus planning and student experiences. Nic, it's all yours.
Thank you for the intro, Bill. Great to see everybody. Appreciate you taking the time to come out here today, and excited to be at my first FLAPA. My goal today is to really not talk at a super high level and about AI hype, but really get to actionable data principles and real world results of what people are using AI for in the facilities and real estate world today. So I hope we can leave here with some actionable insights and not just another hypey AI conversation. But before I dig into all the material, I like to start with a little bit of the background on Occuspace. Why did I start this company 10 years ago, and how did I get here? Because I never thought I would be in the real estate and facilities world that I'm in. That wasn't my dream. I was an electrical engineering student. I wanted to work in renewable energy or work in hardware, get a job at Qualcomm when I graduated from UC San Diego. And my junior year, I hated how crowded all the gyms, dining halls, and libraries were. I grew up about an hour and a half from here in Clearwater, Florida. Not nearly as crowded as San Diego, where I went to college. And I loved San Diego, but I hated how crowded everywhere was. So one day I was like, man, I wish I knew how busy every floor of the library was, the gyms, the dining halls. I should make a sensor that could passively count people in real time, report that data on an app, be a great school project, a resume builder, help me get a real job when I graduate. And I did that. And then when we launched the app on campus, I made one Facebook post and I said, hey, this is how you can see how busy all these things are in real time. On the first day, 5,700 students downloaded the app, and I was like, wow, this is pretty cool. Now this is a great resume builder. And then 2 weeks later, the vice chancellor in charge of real estate and facilities calls me up and he's like, hey, Nic, how do you have all this data on my buildings? I'm spending $1 billion a year on construction at UC San Diego, and I have no idea how any of my spaces are being used. And he's like, we've got 5 million square feet of office space. I walk through these buildings. They're all empty, but every department's asking me for more space all the time. And he's like, can I deploy your sensors to 5 million square feet of office space? And I threw out a number, and he was like, yeah. I was like, okay, I guess I gotta do this. And so I really started to, I accidentally fell into this real estate and facilities world by building a sensor that can measure how people use space. And when the chancellor told me that he was spending $1 billion a year in real estate and didn't have any data on how it was being used, my mind immediately went to the world I knew better at the time, which was the digital world. And I was like, I would never build an app or a website. I wouldn't spend $20 a year on a website without knowing how many people come to that website, what are they clicking on, how long are they staying on certain pages. Yet we're spending billions of dollars on buildings and we don't have that same basic information. So the vision for Occuspace kind of became, can we be the web analytics of the physical world? Can we make real estate more efficient, more data-driven? And so that's how we got here. Fast forward about 10 years. We work with roughly 120 higher education institutions across the US and Canada, dozens of large corporations, and the US federal government as well. We measure their office space and help make it more efficient. And so today we're not going to focus too much on all that. We're going to focus on the AI wave that's coming and that's partially here, and how we're seeing today people use data and AI for actual real world results. And so a couple things I'm going to hit today is just a few high level AI trends. I really want to spend some time talking about data quality, data cleanliness, and what I kind of call the data problem, which is, bad data into AI creates bad outputs. We really have to know our data hygiene to get good results from AI. We'll talk about the opportunity, which is really some benchmarking data across our clients. How is space used today, and where is there opportunity to be more efficient with this space? And then a few case studies with our clients of how they're actually using these AI tools to get some real ROI. So starting off with some high-level AI trends, 90% of organizations plan to use AI heavily. I think that'll be 100% pretty soon. I'm actually surprised it's not 100% right now. And maybe a quick survey of the room so we know the crowd we're working with. How many people don't use AI at all today? By a show of hands. How many people use it, a couple times a week, once or twice a week? Okay, about half the folks. How many people use it every day? About half the folks. Okay, good to know. And we'll touch on that a little bit more. I'm definitely one of the folks that use it every day. I think like one of the AI tools I use was down for like 2 hours in the morning a couple weeks ago, and I felt like I couldn't get anything done anymore. I'm becoming heavily dependent on it. Actually, this whole presentation was all built by AI as well. And I want to talk a little bit about the future state, where I see this really starting to impact things today, and more as time goes on, is really the time to act. The time to get things done is shrinking really massively. And the expertise you need to get things done is really changing. I think today, in some degree, we're becoming people are becoming no longer bounded by our skill set to do things, but more our creativity to prompt AI to help us get things done. And it's a really big shift. Like, you don't have to be a coder to make a website anymore. You don't have to be a video editor to make a video anymore that's AI prompted. You just have to be good at using these tools. And I think what's really happening is a few examples I have here on kind of the time to do things. If you used to want a manual study of how your space is done, it would take 6 to 8 weeks, bring in a consultant, collect that data. They would analyze it for a month and then give you a report, and you'd be looking at 3-month-old data. Now you can get that data in real time. But almost even more important than the real-time data, we can make real-time decisions. So instead of looking at things on a quarterly lagging basis, AI can look at data that streams in and not just give you suggestions, but it can take real-time action, which is just something that I don't think we've really had too much before. And then static spreadsheets, I think, will really be a thing of the past, and we'll just start querying our data. We'll ask our data questions, or we'll ask our data, what questions should I be asking? And it will start to talk to us and speak to us in that way. And so the way we're going to be interacting with data and making data-driven decisions, I think, is going to change a lot to be much more real-time and more natural language over time. But the thing I really want to stress today is AI is only as good as the data that you put into it. I'm sure, like, if you ask ChatGPT, for Mike's spaces at Berkeley Prep, how can I be more efficient with my space? It's just going to give you a bunch of generic stuff. It doesn't know your space. It doesn't know how it's used. It doesn't know your square footage, your cost, your people, your culture. But when you start to feed AI good data, the suggestions it makes can be really powerful and very intelligent. And so one thing that strikes me, and kind of goes back to the origin story, is the built environment, physical spaces, is one of the least data-rich environments in the world. We really struggle to have good data on how physical spaces are used, and the data we have is usually pretty siloed. You might have a lot of data about your HVAC system and about your scheduling system and everything, but a lot of times they're not in the same place. They don't talk to each other. And so getting good data to feed your AI and getting all your data in one place is kind of table stakes to get good AI output. If you can't do that, the AI is not going to be fed intelligent data, and it's not going to give you a very intelligent output. And so AI models are starved for data. They need that, or they're going to be just giving you blind suggestions, and it's not going to be that helpful. So a couple principles for creating AI-ready data sets that I wanted to talk about today. The first one is precision versus accuracy. I think this is a really important, very general data philosophy everybody needs to understand about their data sets. No data set is generally going to be perfectly precise and perfectly accurate. So you have to understand for these different data sets, is it accurate but not precise? Is it precise but not accurate? And understanding that is really important. So this chart on that side shows a couple examples of this on a target board. When you have high accuracy but low precision, if I can actually see all these, you're going to be a little bit kind of a tight grouping, but it's not going to be on the bullseye. High accuracy, high precision, everything's on the bullseye. Low precision, everything's going to be scattered about. In the world of data, you need accuracy up to a certain point, but precision is actually going to be generally more important. You need your data trends to be consistent. Being able to compare data trends over time is often more important than the absolute accuracy, again, up to a given point. You can't just have your data be super inaccurate. But for instance, if I told you 60% of the time, if Occuspace was telling you how every floor of your building was being used, and 60% of the time we were 100% accurate, we were spot on, and 40% of the time we were wildly inaccurate up and down, the entire data set would be pretty useless to you. And so you really need to understand for the different data sets, do I have accuracy, do I have precision, or do I have both? And I just think that's an important principle because no data set is perfect. And when you are seeing AI outputs, if you don't understand the strengths and weaknesses of the data sets that are going into that AI, you can not have the right context to understand the outputs, especially today where the outputs are not always perfect. If you don't know the strengths and weaknesses of the data going into it, you could definitely kind of fall for hallucinations and not spot hallucinations easily. Data portability is, I think, maybe one of the most important principles because if you have good data but you can't move it around to where it needs to be used, it's kind of useless to you. So data portability is really that ability to, whether it's through APIs, through streaming integrations, through data exports, being able to move your data sets into the places that you can pair them with other data sets and get more intelligent outputs. And so anytime you're looking at a data solution, be thinking about its integrations, its APIs, its data exports, so that you can easily move that data to where you need it to be. And then data cleanliness. I think about data cleanliness in a couple different ways. There's kind of contaminated data, and then there's bad data. Contaminated data is data that has personally identifiable information, privacy, invasive information that you don't really want to be feeding into different AI solutions. There's data ownership that you have to think about. When I'm feeding data into any AI or using it, who actually owns this data? Do I own this data? Can I use this data? And then there's just bad data. An example of this is if someone's exporting Occuspace data, and I say, hey, I want to know all the average and peak utilization last week in all my office buildings. And I export it midnight to midnight, 24 hours, that average occupancy is going to be very low because outside of 8 to 5, it's pretty much going to be 0, most likely. So that's where you have to know, like, okay, I want to export the data set that I care about from 8 to 5. And for a solution like ours, it does that for you automatically. But a lot of times it might not. And if you're putting in bad data into these solutions, you're going to get bad outputs. The other couple principles to think about is real-time data streams, which I've talked a lot about a little bit, and I'll hit on in the case studies we talk about today. Privacy and security. Nobody should be uploading any data into any AI that you're at least not paying for that AI, or that AI company will use that data to train their models. And it's a big security implication for your company. So even if you pay, you probably want to be a little bit careful with this stuff because There's more and more data leaks every day coming out of these AI solutions where people are just uploading massive amounts of secure information from their companies and then finding out that it's leaking through those AI solutions later. And then seamless implementation. This is probably the hardest part of AI right now, is actually getting people to use it. And I think you all probably know more about change management than I do. But what I've seen is we have to try to disrupt people's workflow as little as possible. We're not going to, get all the custodial staff in cleaning our building to all of a sudden start adopting AI tools tomorrow. But how can we get into their existing workflow and make it more efficient with AI without having to make them an AI super user? Just augmenting what they're already doing to be more efficient. And so that's honestly the part of the process today that I think takes the most creativity and the most knowledge expertise of really understanding how these people work, what is their workflow, where's the spot that I can start to jump in and make it more efficient without having this huge barrier to knowledge and training. So now I'm going to jump into a benchmarking report that Occuspace puts out after every semester, talking about how is space used across the 120 university clients that we have, about 50 million square feet of space that we measure. What is the data that we're seeing and how that spaces are being used? And that really this kind of points to the opportunity that we have in making these spaces more efficient. So this is for fall of 24 versus fall of 25, how different space types on university campuses were being used. The big movers that I'll highlight here is athletics and rec spaces being down 17%, and then lab space and office space being down 15 and 12%. Everything else, give or take, was somewhat normalized or consistent with the general trend of everything being a little bit down and then dining being up. But rec space, lab space, and office space seeing a pretty big trend year over year in lower utilization. And then overall, pointing out just that most of these spaces are not very highly utilized. They're sitting in the 30s and 40%. And what we're looking at here is not the average utilization through the day, it's actually the average daily peak. So what is the most amount of people that was in these spaces every day that they're operating for the rec center, it's 7 days a week. For the office space, it's 5 days a week. What's the average daily peak? And so in office space, it's 38% is the average daily peak Monday through Friday. The maximum number of people in the space on each day, on average, is 38%. And so that tells us we have a lot of room for optimization in a lot of ways for all these space types. This is one of the most surprising metrics that I've seen in starting to do these larger studies, is the amount of time classrooms on higher ed campuses are empty. And this is the Monday through Friday. I believe this is either 8 to 5 or 9 to 5. So prime time on campus, when classes are scheduled, how often is the classroom just completely empty, not being used? And from Monday through Thursday, it's 25% of those hours. It's empty. On Fridays, I believe it's 37%, which is pretty shocking. And as we've kind of taken a deep dive into this problem with our clients, a lot of times our clients will share registrar data. So we'll see the classroom scheduling. And the problem isn't just that the classrooms aren't scheduled. The problem in a lot of cases these days is that there's a class that is scheduled, that professor has that room, and they're pretty much teaching an online class. They're posting the videos online, nobody's coming. Maybe the professor's in the lecture hall, maybe he's not, but nobody's using it yet. This high value asset on campus is booked and not being used, and you might be thinking we got to build more classrooms to accommodate all this, but little do you know, 25% of the time your classrooms are actually empty already. And so this is a big issue. not just in the class scheduling and construction side of things, but also even in the heating, ventilation, AC side of things. We're heating, cooling, ventilating these spaces as if they're being used, and 25% of the time they're not, which is a pretty big impact on energy costs. Diving in a little bit deeper on office space, we can compare the fall 24 to fall 25 average daily peak and average weekly peak utilization trends. Both trending down year over year pretty significantly. Average daily peak is that maximum number of people that were there Monday through Friday. Average weekly peak is just the maximum number of people that were there the entire week. A lot of times when our clients are trying to optimize office space, they're looking at that average weekly peak number and they're saying, hey, if my IT department has 80 desks because they have 80 people, and 80 people come every Wednesday, maybe they still need those 80 desks. Whereas if their weekly peak is 40, they definitely don't need those 80 desks. And so the point here, 38% average daily peak, 52% average weekly peak, still a lot of room to optimize even on the weekly peak number here. And both trending down despite a broad push in the market to get people in office 5 days a week. And this is a slide we didn't have for this benchmarking report, we'll have in the next one, but comparing the data between universities and organizations that have a 5-day return to office mandate versus a hybrid policy, there's almost no difference in utilization. Some organizations with a 5-day-a-week mandate have lower than average utilization. The mandates just don't seem to be working for whatever reason. And this is averages. Some organizations are really successful with their return to office mandates and get people to come in, and some are peaking at 27% despite a mandate that's like, come back or you're fired. And so there's a lot that goes into it despite that's not just the policies. Conference rooms is the last thing I'll hit on in the benchmarking data, then we'll get into some case studies, and we've got time. So conference rooms is a fascinating one because usually departments don't own this. It's a little bit more of a low-hanging fruit to optimize, but everybody also wants conference rooms all the time. And so the data says a little bit of a different story, that small conference rooms, small or medium conference rooms that are 11 people capacity or less, they're only in use 36% of the workday. Large conference rooms, 12 plus, are in use 47% of the workday. But what's even more interesting than that to me is that when these conference rooms are in use, the amount of people that are using them is not close to what their capacity is. So small conference rooms, which again we're defining as 1 to 11 people, it is, what is that, 94% of the time it's 1 or 2 people. 69% of the time it's 1 person in that conference room. And so they might be saying they need more conference rooms, but they might just need more phone booths because they're on Zoom calls and maybe they don't want to take a Zoom call from their desk for whatever reason. They want to have a little bit more privacy, but all of a sudden they're taking up a 6 or 8 person conference room for a 1-person Zoom call, which is a pretty inefficient use of resources. And we see it even in the large conference rooms, 12 plus people. It's 54% of the time that's being used. It's being used by 1 or 2 people. And so this is the conference room problem is a really interesting balance between employee experience and space efficiency. Because when you ask employees, they will almost always say they want a bigger room. And when you see the rooms fill up, the small rooms always fill up last. They say they want to spread out, they want to put their bag on a chair, they don't want to be too close to people. So they all want a room that only half the chairs or less are being taken, but it's a pretty bad use of resources that are costly. And so that's above my pay grade. That's something for you guys to figure out is how do you balance employee experience with space efficiency. But the data says that we don't need nearly as many large conference rooms as we have today. So jumping into real use cases and case studies today of how people are using AI to get more efficient with real estate and facilities solutions. The 5 buckets we see the most of right now, far and away the number one case study or use case for this data is right-sizing your portfolio. Saying I've got this much space, how much space do I really need? Whether that's office space or classroom space or even student spaces in some cases. And so that's probably the most common. The next 2 is really going to be HVAC optimization and custodial cleaning. HVAC, ASHRAE standards say that if you don't know how many people are in a space, you have to ventilate that space as if it's at maximum occupancy during its operating hours. And so you could have, you know, a library or a classroom or an office space that's 20, 30% full, and you're pumping it with ventilation like it's 100% full that whole time. And in a place like Florida in the summers, or most of the time in the year in Florida, where it's very hot and sticky outside, you're bringing in all that outside air. You're then conditioning it and then pumping it in, and that takes a lot of electricity. So if you can actually ventilate it based on the actual occupancy, we see customers generally saving 10 to 15% of their total building energy consumption is lower when you do demand control ventilation. Custodial cleaning has been probably the biggest use case of the last year we've seen, and I'm surprised it's taken this long to become popular because intuitively, I think we all know a floor that's 15% utilized shouldn't take the same amount of labor hours as a floor that's 75% utilized to clean. And so now we've got clients really using this, and one of our higher ed clients at UCLA, I think they are saving $6 million this year in lower custodial cleaning labor hours. And they're even getting into some of the crazy future stuff. They have our API pinging their custodial cleaning robots to clean spaces based on when people use it, or when 100 people take a trip to the bathroom, you know, ping the staff that it needs to be cleaned and restocked, or whatever number they deem for those spaces. So custodial cleaning is a really interesting one, and I think it's a low-hanging fruit. I'll get into that actually case study a little bit more. Service alignment, batch food cooking, and then capital planning, which is the big one. How much space do I need? Can I shed leases? Do I need to build a new building? We're working with a university right now. They've got 900,000 square feet of office space. They think, you know, they're growing enrollment. They're like, by 2033, we need 1.2 million square feet of office space. And we come in and we start measuring their space, and it's like, you probably need 600,000 square feet of office space. You don't need to be growing. You can probably be shrinking. You can be shedding your leases and not building new spaces. So let's get a little bit detailed. This is a UCLA case study. Their goals were, can we reduce our labor hours by 20%? Can we almost slash our overtime hours by close to 100%? I think their goal is 80% here. Can we improve safety, lower workers' comp claims, improve our CSAT scores, and our consistency in this? So it wasn't just, can we save money on custodial cleaning? It was, can we save money on custodial cleaning and actually make our work output better for the people that are using our spaces and for the custodians? And so the results of this was 20 to 30% reduction. I believe UCLA thinks they can reduce it by 30%, but right now they're reducing it by 20% for labor hours. For them, and it's probably a problem for a lot of people, they can't hire enough custodians that they need or that they thought they needed on campus. So what our solution is really doing for them is allowing them, with a worker shortage, how do we use the employees we have to still cover the spaces that need to be covered and do an adequate job when we can't hire the people we need to? And so they're saving $6 million a year across 5+ million square feet of space that we measure for them. And the way they implemented it, we worked with them and with a consultant called Core America. And I think this is such a brilliant example of the seamless integration I talked about that I think is the hardest part of AI right now. And the way they did it is they made new route cards that you can see on the screen. And those route cards have a task list A, B, and C for the custodians. It says, if this floor is between this utilization, do this task list. If it's between this utilization, do this. If it's between this, do this. And it's kind of like I think they called it trash and dash if it's below 20% utilization. If it's between 20 and 50 or 30 and 50, it was like a medium clean. And then if it was over 50% utilization, do a deep clean. And so every day, they have all those laminated task cards on their carts. Every day their shift manager gets an email at 5 p.m. and it says, for all the spaces you manage and your team clean, here's how they were all utilized. And we're going to flag the ones that were more anomalous. Like you're already doing in your monthly scheduling, you're changing all your scheduling based on the previous month's trends of data in these spaces. We're going to email you every day and let you know if any of those assumptions about the next month are wrong. And today, hey, your marketing team had a pizza party. Everybody's in. We thought that nobody was going to be in there because nobody really came in last month, but we got to clean that space today. Or there's an event that wasn't on the books. We got to clean it so that nobody's complaining tomorrow. And so if any anomalies happen, they get that email every day. They can adjust resources on the fly, and they can stop cleaning spaces that have been cleaned 17 times since the last person came in, which is a lot of spaces on a lot of campuses. There's a lot of empty office spaces that don't get very utilized, yet they're being cleaned like they're being fully utilized all the time. And so this implementation, very low tech, very easy to implement using route cards, monthly optimization of scheduling, and then a daily email. Nothing too deep integration. The hardest part is probably the monthly scheduling, but it's honestly not that hard. It's such a perfect use case to be able to feed the data to AI, feed all the spaces, the square footage, how fast your custodians clean, how many people you have, utilization data, and AI can do that optimization of scheduling for you. So one of my favorite case studies, here's one of demand control ventilation. We didn't invent demand control ventilation. It's something that every BMS, every HVAC system has baked into it, or at least anything deployed in the last dozen years or so, where you can change the ventilation rates based on occupancy data. And so pre-demand control ventilation, the green line is your ventilation, the blue or teal line is the occupancy, so it's just flat. It's going to be flat throughout your operating hours. When you incorporate occupancy data into it and actually do demand control ventilation, you're changing your ventilation rate throughout the day based on how many people are actually there. We had one client that was saving 50 cents a square foot a year just in energy cost in a very hot place. Usually it's going to be somewhere between 15 and 25 cents per square foot a year in lower energy costs by doing demand control ventilation. And then this is another exciting one that was customer-led. They made this whole case study and use case without it ever being something that came to our mind. This is a large Fortune 100 company. They have a lot of offices. All their offices have cafeterias in them, and they feed their employees, and they pay for their employees' food. But post-COVID, a lot less people are showing up to the office, but they're cooking the same amount of food. And they were throwing away, I mean, it was like hundreds of pounds of chicken a day that was being wasted. And so they brought us in. We measured their entire floor for, I think, for at least 16 buildings that they have. Every day for each building at 10 a.m., we ping the Sodexo staff that runs the cafeterias. This is how many people are in the building today. Make food for this many people. And then they do all their batch cooking. They change how much food they're going to make. They've reduced their food waste so far by 20%, which I actually think they should be a lot more, but they're still being a little bit cautious, and they'd rather over-prepare than under-prepare. But they've reduced their food waste by 20%, which is giving them a 2-to-1 ROI on the cost of Occuspace measuring all their buildings, without custodial cleaning optimization, without HVAC, without space planning, just on less chicken that we're wasting, essentially. They're getting a 2-to-1 ROI. And another one of these kind of low-tech integrations, we're just sending an email to the chef of truly to the whole the Sodexo staff of every cafeteria at 10 a.m. every day. And those folks already have the expertise that they know how much food they need to cook based on how many people are going to come. They just don't know how many people are going to come to lunch. And so if we give them that data point, they have the extra knowledge to change their food batch cooking and get some real savings. And so these are what I call like the seamless integrations or seamless implementation of data in people's workflows where it doesn't disrupt their workflow very much at all and can lead to real savings. And I got a couple of case studies at the end here on right-sizing office space and want to dive in a little bit specifically. This is like a zoomed in look at how people make these decisions. So our clients generally have at least 500,000 square feet of office space usually. This is one department and how they make a decision on one department. This department had 78 full-time employees. We started measuring it. We said there's 57% peak utilization, 34% average utilization. They surveyed that department. What we usually say is the data by itself isn't going to give you all the answers. It's going to help you ask the right questions. It's going to be a conversation starter with this department and say, hey, we see you're not really using all your space here. How can we make this space better? Do you want to come in 5 days a week? Do you want to be remote? If you want to be remote, we're okay with that, potentially, depending on your organization. But you can't be remote and have an assigned desk for everybody. And so that's a conversation that this data can start. Usually goes like this, where you survey the team, you talk to them, okay, who is coming in 4 or 5 days a week? You can keep an assigned seat. Other people are going to go to shared seating, and we're going to have a different breakdown of the space. In this example, they reduced their space by 32% and improved employee satisfaction. That's one of my favorite parts of this is a lot of times you're going to get a lot of pushback if you tell people you want to go from assigned seating to shared seating. But once people actually go to shared seating and they're 2, 3, 4 months into it, they realize, hey, I'm actually always going to have a seat still anyway. The office is still not packed. There's this fear of not having a seat that's really not true. You're never going to plan for it to be at 100% capacity. You're going to plan for it to be like at 70 or 80% capacity for your weekly peak. And so people always have a seat. They have better experience. The office is more vibrant. The most negative experience people have today is commuting into work, sitting in a ghost town of an office and being on Zoom calls all day. But if you can reduce that office size, make it feel more vibrant, there's actually people here, people have a better experience in the office. Here's a very similar case study. They had 90 desks, but a lot lower utilization, and the university had a lot more of an aggressive cut to their space, reduced their space by 75%, went from 90 desks to a little over 20 desks, and avoided leasing a new building. Really, they were about to lease a $700,000 a year space because another department needed more space and was actually coming in. It was actually the police department in this example. And instead, they were able to shuffle around departments with this space that got freed up, and nobody had to lease any additional spaces. So we've got just a couple minutes left. I want to save a few minutes for any questions, but the last things I'll leave everybody with is that, again, AI is only as smart as the data. So I think we need to start trying to measure everything that we can. If we want it to be really improved with AI, we need the data to power that AI. The second thing is, for that data, no data set's perfect. You have to really understand the strengths and weaknesses of your data set, make sure it's a clean data set, and that it can be portable and it can be integrated into wherever your other data sets is. Even occupancy data by itself, really interesting, but if it's not paired with the square footage of the space, how many workstations there are, how many people are assigned to it, the energy consumption of the space, the custodial cleaning lift on the space, it's going to be a lot less useful to you. And so the data's all got to be able to be pooled in one area, be portable, and then those simple implementations. I think that is the hardest part, and that's kind of the name of the game right now is how do we make improvements where the change management lift isn't so high, especially in real estate and facilities. I think We can't just turn to our whole organization and say, hey, everybody needs to start using ChatGPT every day for everything. People just aren't going to do that, or they're not going to do it well, at least, because these tools still make a lot of mistakes when you ask them things. So how do we make sure we piece out the specific data points and specific actions we want people to take, insert it into their workflow in a seamless way that they can do their job better and they feel like it's helping them. It's not a new thing that they have to learn. So that is it for me. I think we got 5 minutes left if there's any questions from folks.
Does your system require maintenance?
Every sensor plugs right into a wall outlet. It covers about 3,000 square feet, connects to cellular, so we don't sit on your IT infrastructure. The only time we ever need maintenance is if someone unplugs and steals a sensor. It's secured pretty tightly. They'd probably have to break the faceplate off to take it off. Here's a funny thing. So I started, and I remember when I started it as a student, I was deploying to the gym at my campus, and the guy at the gym was like, oh my gosh, students are going to be coming in here with screwdrivers and wrenches. It's going to be gone in 4 hours. And it never happened. Students never, almost never, much less than 1% of our sensors get lost in student spaces every year. Where they get lost a lot more is in faculty office spaces. The faculty are much more sensitive to data that says they don't use their spaces. And it's, with students, like, they actually like it. They're like, oh, I can see how busy the gym or the library is. This is of use to me. I like this. The faculty is like, I've got 3 offices across campus and I come once a month. This data is going to take away my status symbol. And so they start knocking them off. But it's still a very low amount. And when they come offline, we see it instantly and we ping our facilities rep on the campus and we can get it replaced. And when one goes missing, we replace it with a more secure version of it that you got a set screw and it's pretty much impossible to break.
You said it uses cellular. We've got a lot of places that cellular, thick walls, almost bunker level, at some of our campuses. Is there another? Yeah,
we can do connect to your Wi-Fi. You can spin up an IoT network or a hidden network or something like that. We can do PoE. We can do it. Just most people for most spaces, cellular is a lot easier.
Yeah, it would definitely be a lot easier, but nice to know that both are options. I missed the first couple minutes, so I apologize, but I'll stop by your booth too and talk a little bit more. But how does it know that there's 7 people in a conference room over one? Because the dumb occupancy sensors that we've used in the past just basically say something was moving in the room.
Yeah.
And by the way, talk about faculty getting smart, just like people on working remote, have the little mouse click. So people have figured out how to do something in their office to make it look like there was movement. So they were occupying it, but there really wasn't, that they've got a hamster running in the corner, or whatever. So, yeah, I just want to hear, how's the technology work?
And put a cardboard sign on like a Roomba and have it run around there or something.
How do people get creative? Attach something to a fan that it would just, so the light stayed on.
There's got to be there's a little bit of respect for the people that could be creative. But the way our technology works is we're scanning for Bluetooth and Wi-Fi signals in the room. So we see all the laptops, phones, smartphones, headphones, iPads, watches, everything that emits a Bluetooth and Wi-Fi signal. What we do better than anybody else in the world is without connecting to those devices, without needing them connected to the access points, we know what type of device a signal is coming from. So we get to how many phones are in the room, how many laptops are in the room, and then our job becomes how many people have 1 phone or 2 phones. And we can tell that based on how they're moving throughout the space. Are they always together? Are they moving in different directions? Is it 2 phones and 1 laptop? Is it 2 phones and 2 laptops, et cetera? And we're not perfect, but we're on average between 95 and 97% accurate.
That's awesome. Thank you.
How about integration with building automation systems?
Yeah, we have API, we do backnet integrations, we do data streaming integrations, so we've worked with a lot of different BMS, BAS solutions on the market, integrate into a lot of IWMS and space management, IBM Tririga, Archibus, Planon, Schneider. We're doing an integration with a campus right now in Florida that's got 7 different HVAC systems on their campus. That one's a little bit more tricky, but it can still be done.
Okay. You ever run into any issues when you're taking up wall outlet space, like from the space of charging laptops, doing something else, or for the blank slide you're taking up? You have to take up many of the wall outlets in a room.
Yeah, with one sensor every 2,000 to 3,000 square feet, we're not taking up like all the outlets. If it's a modern building, it's not ever an issue. If it's an old building that has a lot less outlet availability, it can be a little bit more tricky. And sometimes we'll just like bring an outlet splitter if it's a real issue, and we'll just take, one of like the 3 spots and add to it. But in general, we're taking like 1 out of every 10 plugs in the area. Our sensor covers up one of the outlets. It doesn't cover up both of them. So it's not a big issue, but in old buildings, it can sometimes pop up.
Kind of to that point, office spaces, is a sensor needed in every office, or is it? So I've got a floor and a wing that's probably 6,000 square feet, but it's 40 offices or whatever.
Yeah.
Because again, our old dumb ones, we would need 1 for every single space. Basically, if it had 4 walls, we needed a sensor at least, and sometimes more.
So it depends on what you want. We offer different levels of data granularity depending on the solution, the way you have your teams allocated in your space and the problems you're trying to solve. So we can just report at the floor level how many people are on the floor every minute of the day, or we do the neighborhood and meeting rooms individually. And so we can break it up a lot of times by neighborhood where a department is allocated to sit, but we're still only putting a sensor, if you break it up by neighborhood, 1 every 2,000 square feet in general. We're not putting them at every desk. We don't do desk level measurement. I actually think it's kind of a waste of money. You have 2,000 desks. I promise you're not going to be wanting to look at every desk's utilization. You don't have time for that. And it also creates a lot of privacy issues with your employees that you just don't want to go down that rabbit hole. So at the department level or floor level is really where most of our clients want to get the data for. And we don't have to do a sensor at every desk to do that.
Do you guys provide the equipment and help the install, or the customer purchase your equipment and third-party install? How does that work?
We either will do the install ourselves or some customers will self-install. Because it's literally just plugging a sensor into an outlet, it's not very difficult. And so, somebody who's pretty untrained could install 100,000 square feet in half a day, walking around plugging sensors in.
So is it an annual service that you pay for?
Yeah, it's somewhere around like 10 to 20 cents a square foot a year, depending on the level of granularity and the data that you want. Awesome. Thank you for the questions. Thanks for the time, everybody. Appreciate it.